We humans are very curious. We have been trying to find out patterns in almost everything. We look up at stars and see if there is any pattern in them. And indeed, we did find some patterns over there. And similarly, we have been trying to look up at all the chemical reactions and trying to see if there is any pattern that exists between them. And we did find many patterns over there. And today we are going to talk about one of those patterns. So we saw that there are some certain chemical reactions in which oxygen gets added. And then there are certain chemical reactions in which oxygen is removed. And we gave them special names. We call them oxidation and reduction reactions. Oxidation meaning oxygen is getting added. Oxidation, oxygen is added. And reduction is the opposite of that. It just means that oxygen is removed. Well, there are many more things happening under oxidation and reduction. And that's what exactly we are going to talk about in this particular video. So let's begin. First, let's look at a few examples and see if we are able to identify oxidation reactions and reduction reactions. So here I have a few examples. But before I solve and show it to you, why don't you pause the video and see it for yourself? Now, if you have given it a try, let's see. This is my first example. Here I see that magnesium is reacting with oxygen to give me magnesium oxide. So here I can see that oxygen is getting added to this metal here, right? So this reaction is going to be oxidation. Oxygen is getting added, right? Now this is the second example. Here I see that zinc oxide is reacting with carbon and giving zinc and carbon monoxide. So if I focus on zinc, so see, initially it was combined with oxygen, but finally it has lost the oxygen. So zinc is losing its oxygen. So we can say that zinc is going through reduction reaction, okay? But over here in the same reaction, if you focus on the carbon, see, carbon was without oxygen to begin with, but after the reaction, it is combined with oxygen. So, okay, there is oxygen addition happening to carbon. So this means that in the same reaction, we can say that carbon is going through oxidation reaction. And yes, a same reaction can have both oxidation and reduction. And we call such type of reactions as redox reactions. And don't worry, we will talk about this reaction in much detail in a separate video. Now let's come back to the third reaction. Over here we see copper oxide is reacting with hydrogen to give us copper and water. So if I focus on copper, so before reaction it was combined with oxygen. But after reaction, it has lost its oxygen. That means oxygen is being lost by copper. So over here I will say that copper is going through reduction reaction. But if we focus on this hydrogen, see, hydrogen did not have oxygen to begin with. But after the reaction, it is combined with an oxygen. So I will say that hydrogen is going through oxidation reaction. Oxidation. Now this is the fourth one. Here we see that oxygen is getting added to copper and we get copper oxide. So this reaction is oxidation reaction. Copper is going through oxidation reaction. Over here we see that oxygen is getting added to sodium and we get sodium oxide. So here I would say sodium is going through oxidation reaction. So now we have solved our problem. Now let's look at what else is there in oxidation and reduction. So far we have seen the oxygen's addition is termed as oxidation and oxygen's removal is termed as reduction. But you know what? We can even define oxidation and reduction in terms of hydrogen. Yes, we say whenever hydrogen is removed, we call it as oxidation reaction. And whenever hydrogen is added, we call it as reduction reaction. And I know that you might be wondering, like, why are we talking about hydrogen? Where is this hydrogen even coming from? And why is the effect of hydrogen opposite of oxygen? I mean, in case of oxidation, oxygen needs to be added, whereas hydrogen needs to be removed. Or in case of reduction, oxygen needs to be removed, whereas hydrogen needs to be added. So why is this opposite effect happening? So don't worry, I will try to give you some insights about these questions towards the end of the video. But for now, let's try to understand this new definition and try to solve some problems. Now here I have some examples. And before I solve it, why don't you pause it and try it yourself? Just remember one thing, okay? The effect of hydrogen will be opposite of the effect of oxygen. Meaning in case of oxidation, oxygen was getting added. Whereas in terms of hydrogen, we will say that hydrogen will be getting removed. Similarly, in case of reduction, oxygen was getting removed, whereas in case of hydrogen, we will say hydrogen will be getting added. So now go ahead, pause the video and try it yourself. Now, if you have tried it, let's see. In the first equation, I have a compound over here that has many hydrogens. And after the reaction, I see that it has lost some hydrogen. So meaning this compound is losing hydrogen. Hydrogen is being removed from here. So which reaction will this be? So remember, removal of hydrogen could be thought in terms of addition of oxygen. And addition of oxygen is oxidation. So here this compound is going through oxidation. Let's write it down. This compound is going through oxidation. Similarly over here, I see carbon monoxide is reacting with hydrogen and hydrogen is getting added to it. We get one single compound, right? So here I would say that since hydrogen is getting added over here, then this reaction will be, so addition of hydrogen can be thought in terms of removal of oxygen, which is reduction reaction. So over here, carbon monoxide is getting reduced. Let me just write it. This is getting reduced. Okay. Now let's look at the third example. Here I see that, methane was reacting with oxygen. So see, methane had 4 hydrogens, but after the reaction, I see carbon has lost all the hydrogens. Here carbon has lost all the hydrogens, right? So which reaction is this? Hydrogen is getting lost, removed. Okay, so hydrogen removed is like saying oxygen added, which is oxidation. So yeah, here carbon is getting oxidized. So now we have spoken a lot about oxidation and reduction reaction. We have defined them both in terms of oxygen and also in terms of hydrogen. We still have a question. See, we named the reactions in which oxygen was getting added as oxidation. Why did we give the same name to the reactions in which hydrogen was getting removed? But see, in reality, both of these definitions are kind of old definitions. And the new definition of oxidation and reduction is based on electron loss or electron gain. And that will help you understand where is hydrogen coming from. So let's talk about that very briefly. So if you take an element and you burn it in air, it reacts with the oxygen present in the air to form an oxide. And I have some examples here. Over here you can see that magnesium, when burnt in air, it reacts with the oxygen to form magnesium oxide. And since over here oxygen is getting added to magnesium, we call this reaction as oxidation reaction, addition of oxygen. Now when we were defining oxidation as addition of oxygen, we did not know anything about electrons. We did not know what is happening between the electrons of these two elements. Are they being transferred or shared or anything at all? But later on when we found out, we saw something like this. When magnesium was combining with oxygen, it had to lose its electrons to oxygen. Similarly, in the case of sodium oxide, when sodium was getting added to oxygen, both the sodium atoms, they were losing one electron to oxygen. Similarly, we saw in all the oxidation reactions that the elements, they were losing electrons to oxygen, either fully or either partially, but they were losing electrons. So this helped us upgrade our definition of oxidation reaction. We no longer depend on oxygen for that matter. As long as in a reaction, an element is losing electron, we see that element is going under oxidation reaction. And it could be doing so because of any reason. Because of oxygen, because of hydrogen, because of sulfur, nitrogen, any other compound. As long as it loses electron, we will call it oxidation. So it turned out that whenever we add oxygen, the element loses electron. Whenever we add oxygen. Similarly, whenever hydrogen is removed, the element was losing electron. So that is also termed under oxidation. You could find something very similar for sulfur, for nitrogen, for other compounds also. But now you know why hydrogen came into picture, or you have some idea at least. Now see, this is a new definition for oxidation and reduction, and we are not going into detail of it. There is much more to this, and we have discussed that in a separate video. In this particular video, we are only talking about the conventional definition of oxidation and reduction, which is oxidation is where oxygen gets added or hydrogen is removed, and reduction are those reactions in which oxygen is removed or hydrogen is added.